I think we're good to go.
All right, great. So my name is Mike Mastanduno. I'm a data scientist on the Health Catalyst data science team. And thanks everybody for coming out. And all right, great.
Sorry.
No worries.
Making sure it looks good. So.
And yeah, I want to talk about kind of some of the work we're doing here using R, and maybe hope to teach you guys something about machine learning in the process. So before we get started, thanks Levi for organizing, Andrew for hosting. Look forward to doing more of these in the future and being on the other side of the podium as well. Just for background, I am a biomedical engineer by training. I did my PhD in imaging and then went on to do a postdoc in image reconstruction algorithm design. So I wrote algorithms for ovarian cancer imaging using ultrasound, and then I decided I didn't really like the funding situations in academics, so I ended up here as a data scientist, and it's been great so far. So with that, let's get into the healthcare AI, which is kind of the R package that we've been building here to help machine learning. And so we can go through a little bit about Health Catalyst, just in case you guys don't know. It's mostly just for context. I'm not trying to sell the company here. But it helps you have some context. And then we'll go through kind of like what the goals of healthcare AI are at a high level, kind of dive into the features and what we built and why we built it, and then kind of what we're doing as far as the healthcare machine learning community is concerned. And then finally, we'll just kind of say like, okay, well, we built these tools. Have we used them? Well, yes, we have. And I'll give you a little bit of a thing on how we've done that. And then finally, we'll go into some of the stuff we want to go. And it's an open source project, so you guys definitely would have the opportunity to help shape that if you want to contribute. And then we'll do a little demo just to kind of show the package in action. And then finally, I'll take a lot of questions. I'll probably have 20, maybe 30 minutes of slides, so feel free to interrupt me, and yeah, no problem. So first, Health Catalyst. What does Health Catalyst do? It's a data warehousing company with the main goal being healthcare outcomes improvements. And so we try to generate those healthcare outcomes improvements by storing data, managing data, and then providing insights from that data to better patient care. So an application that we write on top of a client's data, and the clients are hospitals, might be something like which emergency department at your 15 hospital system is performing the best, which one's performing the worst, or kind of, what interventions have you guys used for diabetes patients and which one is the most effective, and here's the data to show it. So that kind of application. And the company is really trying to transform into a machine learning company. Oh yeah, the network's
Finicky?
it can be, yeah.
All right, I think we're back on. So
Okay, we're back
if you
on.
want to back up, that's okay.
As I was saying, so we want to provide a tool set for basic and advanced users, and then we want to lead a community so that people have some way to anchor themselves into healthcare machine learning. So healthcare AI features, how are we doing this? The big picture is that we're trying to simplify the machine learning pipeline, which is a long process of getting data, finding a question to answer using that data, building a model, validating whether or not that model is good, and then using that model in the future. So we're trying to simplify that pipeline, and we're doing it through automation wherever we can. So if one step of the data pipeline is typically drop columns that have too many null values in them, we've written a function into the package that just kind of profiles every column and says, oh, there's a lot of nulls in that one, just get rid of it, put a notification to the console that says that column had too many nulls, we got rid of it, sweep that under the rug. And then interpretability is another big one. So kind of using models that are easier to follow, they're less of a black box, and you can really dig in and say, this is why the model predicted what it did. So that's one, that's kind of the user's perspective. The next one is we see a lot of times that in academic studies, especially in healthcare, the models kind of get made and are validated, and some of them are really good, but they never make it to production to see patients. And sometimes that's because of HIPAA or IRB stuff with academics and the healthcare system. But sometimes it's just that being able to talk nicely with the production environment and all the SQL servers and the electronic data warehouse, electronic medical records, all that infrastructure stuff is pretty complicated. And so we see there's a big roadblock there that healthcare AI hopes to help people address. And then the last thing is we're trying to kind of be the center of this community, and so providing a toolkit that's standardized across versions and has documentation to go with it. It's unit tested, and we have support. So kind of check those boxes as well to encourage people to use our software and not cobble together their own code that they then pass to somebody else when they leave the company, and all of a sudden the model's not really being used. So
sorry to bother you. What does unit tests mean?
So a unit test is it's a software thing that basically is like if you expect a function to behave some way, you can write another function that will test that it does behave that way every time the package is built or changed or loaded. So 2 + 2 will always be 4 within your package, and it's automated. It's under the hood, and you can do it for every function you write into the package, just so when you make a change, nothing surprising happens. If something breaks, the unit test will tell you.
Thanks.
Okay. Chime in. And another really important thing about unit testing is so that when the packages that you're depending on make changes, they can know and let you know that they are going to break your package when they upload it to CRAN, because that happens to me often.
Yeah, that's a great point. Yeah, that's a great point. So package dependencies, because we're not going to reinvent the wheel and write our own from scratch, so we're going to use other people's. So then, so those are kind of that's the big picture of the feature, or the features. Kind of the big picture of the community is, the first thing we did was, we got to start a blog. So we started a blog, and it's mostly our team that's contributing. So we're in the back, and then we've had a guest post from an MD on staff and about sepsis. And so, these posts are anything from here's how you could use machine learning in healthcare to here is what an area on receiver operating characteristic curve is and why it's useful. So trying to provide knowledge, but also be more interesting. We've started doing a live broadcast on YouTube Live where Levi and I just talk about machine learning once a week for half an hour, and that's been fun. We've had 3 or 4 people watch that. So. And we have a Stack Overflow tag. So if you ask a question to Stack Overflow and tag it with healthcare.ai, we'll see it and we'll be able to, help you with your question, as well as, the rest of the community can chime in, because that's what Stack Overflow is for. And then finally, it's open source. So, even the development is kind of democratized. We want to get people to develop it. And I think that's an interesting thing to point out. Like, this package is not something that Health Catalyst is trying to develop and sell. This is the tools themselves are not all you need. Like, you can't just give somebody a circular saw and say, like, oh, can you build me a bookcase? They need to have the knowledge of how to do that too. So the tools themselves are not enough. So Health Catalyst is benefiting by selling the things those tools are used to make, but the tools are made freely available so that anyone can contribute to them or use them on their own problems. So let's dive in just a little bit deeper to some of the features. I'll give an example of each one. We can talk about them more later if you guys want, or we can just leave it at that. So data cleaning, I think I already talked about, counting nulls and dropping columns that have too many null values. As an alternative to that, you could impute the column, which means kind of take a representative number like the column mean and just put that in place of the null, and that's automatic. If you have too many nulls, imputation starts to break down, and the package will give you a little warning saying, like, we want to impute automatically, but you have too many nulls, you should consider dropping the column. Would you like to do that? When you're building machine learning model, just show of hands, how many people are familiar with machine learning? Just for me. Okay, so about half and half. So when you're building a model, you use some data to train it, most of the data, and then you reserve some aside to test it. So there's a bunch of different ways to do that. Healthcare.ai kind of sweeps those under the rug, and you can, it'll split your data for you. And then hyperparameter tuning, which is kind of like, if your model is a stereo, you need to make sure the treble and the bass are tuned to the appropriate level for the model to work. Healthcare.ai can help you do that automatically if you ask it to. It takes a little longer, but you get the best values out. And then finally, just guidance on kind of what the model is and why you might, change certain things. And anywhere in the process where it kind of a line to the console would say, like, you might consider doing X, Y, or Z. We've tried to, anytime we would provide that guidance, we've tried to do so. There's currently 3 algorithms in the R package. We have a lasso, which is a linear model, a random forest, which is an ensemble model, and then we have a linear mixed model, which is a mixed effects model. Neural networks with an asterisk is in the future, because we're not really sure how that's going to interact with the Python package or the R package, but it's going to be part of the functionality at some point in some capacity. And one of the neat things about the package is that the way the architecture is designed, we have this supervised model class, which has all of the parameters that all 4 of these models need. And so when you create this class with your data, you can then change out and try a different model with any of the lines, or with any of the models. You don't have to change any parameters. You can just say, lasso is okay, but let me try random forest. You just change lasso to random forest and it works. So that's a nice way to do model comparison. Another thing I talked about was SQL integration. So getting over that hurdle of getting the model into production, we've used RDBC to give the package direct SQL read-write access. So, in the clinical workflow, normally a doctor is going to be entering information about the patient into the EMR, or the EMR is going to be surfacing information about the patient. And so you can pull historical data directly from the data warehouse, which is where all that data is stored long-term, using SQL queries that are right in the package for model development. And then when you're ready to actually push that model to the production server and use it daily for predictions, it'll help with pulling the newest data lines from the server and writing them directly back to the server, so that the people doing the visualizations or the click apps can kind of see the predictions as if they're any other column, like the weight or BMI or that kind of thing. So kind of we're trying to do seamless integration in a way that's both useful and easy. And I think that's a real strength of the package, not of our DBC, however. So then interpretability, as I said, we've tried to provide guidance through the whole process. So anywhere we can give a suggestion, we'd like to. The models we've chosen are kind of simple, transparent, they're pretty fast, except for linear mixed model. And they're mostly specific to healthcare in that, linear mixed model, for instance, you can do a good job of capturing multiple visits from the same patient and having that kind of be used in a way that would be more beneficial than just calling each visit a separate occurrence. All the models provide feature importance. So, here's like a graph of a diabetes prediction model where saying the systolic blood pressure is the most important feature. And you can use that when you're developing a model to kind of get your data. You could drop a column if it's not useful, like this. So there's that gender flag. You could drop that if it wasn't useful compared to the others. And then on the back end of the model, we've tried to implement explanations of the predictions. So it might say for Joe, we provided this risk score, and here's how we came to that calculation. And then prediction improvements as well, like Joe had this risk score, but if he were to lose 20 pounds, that would be the most bang for his buck as far as lowering that risk score. So that kind of stuff, the explanations are done and being surfaced as as just columns in a SQL database. The prediction improvements, that's something we want to work towards. And then finally, just the software engineering standards. So we have documentation with versioned examples, documentation, the installation tools. I should say the documentation is built with Roxygen, which is really cool. And does the unit tests. So we've kind of pulled together a lot of pretty awesome R functionality to build up examples in the documentation. And then installation is done it's on CRAN now, so that's fairly moved into financial and operational stuff. And I'll give examples of those too. So this is an example of a CLAPSI model, which is it's a central line associated blood infection. So if you're in the ICU and you have a central line that could become infected, we built it for a 15 hospital academic health system, and CLAPSI has a mortality rate of 25%. So it's something that we want to be able to identify as early as possible, even before it happens. And so the model's used for clinical resource allocation. It was built on 70,000 rows from CLABSI patient victims based back to 2012. The DA used kind of the feature selection stuff to take his 23 variables, cut them to 17, so that it would run a little faster. And he got really good results with the model. We use this thing called an ROC curve. How many people are familiar with those? Okay, so a lot of statisticians in there. Yeah, so the ROC curve accuracy, which is kind of the metric we use for all of our models, and I think that's the metric the industry should be going towards, was really high with 0.87 out of 1. So I have a quick aside about ROC curves, which I'd like to go through just because they're complicated and they're useful. So maybe you've heard of them, maybe you haven't, but so machine learning algorithms give a probability typically, which is a number between 0 and 1, and they don't output a binary prediction. But a lot of times you want to tell the doctor, you know, this patient is green, this patient is red, like focus on the red one. You know, you don't want to have to necessarily worry about, oh, that was a 0.74, and the doctor's saying, well, what does that mean? So you have to kind of pick a threshold of like what you want to appear green and what you want to appear red. And when you do that and then talk about how accurate your model is, that's kind of dubious because the threshold is hidden. You know, you don't know what it is unless somebody tells it to you. And you can always choose the threshold based on certain characteristics of accuracy and hide other things that your model's not good at. So if you have, you know, kind of this, you pick a threshold and then you can get one of 4 cases. You can get, you know, so over here we have actual values, which are, you know, in this example I'm going to use, it's an antivirus software trying to find antivirus files. So you have the actual, whether the file is a virus or harmless, and then you have the model's predicted value of whether the file is either virus or harmless. And so those things kind of mean a true negative would be, you know, when the antivirus ignores a harmless file, you're happy about that. A false negative, which would be the antivirus fails to detect a virus, and you're not happy about that. A false positive is when the antivirus calls a harmless from 0.5, which is random, to 1, which is perfect, meaning you got all the positive ones positive and all the negative ones negative. And so that's nice because threshold is erased. You don't have to talk about threshold anymore. It's just one number that encompasses all thresholds. So this is all information from the last slide, just in case you want to look at it. But you know, the threshold dictates the accuracy of the model, so it doesn't make sense to not talk about thresholds using an accuracy metric. But if you use area under the curve, that's threshold independent. And so, you know, the true positive rate and the false positive rate kind of have to be balanced. One comes at the expense of the other based on what you're trying to solve or you know, your specific use case. And so, you know, you might have a case where you pick a threshold that would correspond to up here, where you flag all of the viruses, but you also flag a lot of clean files for inspection. And maybe that would be something like a simple blood test. Whereas there's other cases where, you know, you flag only viruses, but you also miss some viruses because you're too stringent with your criteria. And that might be something where the follow-up is really expensive, like cancer treatment. And then usually you'd want to pick some kind of happy balance that's, finding most of the viruses without flagging too many. So sorry, I wanted to go through that though, just so we can talk about the models. So I'll go through a couple more models. I can run through them. We did a COPD readmissions risk, which is a pulmonary disease readmission risk. So how likely is a hospital to come back to or a patient to come back to the hospital after they're discharged? And that one had 32,000 rows. It's a Canadian hospital or international. And they cut 73 variables down to 20 with an AUC of 0.73. And then as an operational example, we had a rural medical center saying we have a problem with no-shows. A lot of patients are no-showing to their appointments. They're expensive. So we tried to build them a no-show risk model to allow them to either double book slots that were unlikely or were likely to no-show, or to allocate their reminder calls and are you going to be able to come to your appointment type messaging. And that was a big data set, 10 million rows, and the AUC was 0.72, so pretty good. And then finally, we had a propensity to pay model, which was like, will a patient pay their bill? And the use case for that is, again, resource allocation with charitable services or reminders as months go by. And that one's also sitting at 0.72 in production. So for future functionality, we want to keep developing these data cleaning and profiling tools. And those kind of really are the cutting edge of machine learning at that point. Automation and sweeping that stuff under the hood is hard, and people are still in disagreement about how to do it. We want to make things more interpretable. Again, that's the cutting edge. So it's kind of cool that we're able to be in healthcare, which is so far behind, but still be contributing to the greater community, which R has a big part of. We want to add more SQL support with, not just Microsoft SQL Server, because that's all we support right now. Again, neural networks, unsupervised learning, and more customizable advanced functionality. So one thing I wanted to point out with interpretability is this package called LIME. That's kind of like, it builds machine learning models on machine learning problems to be more interpretable. And there's no R package in existence right now, so we kind of have a LIME-like functionality in ours, but we're maybe getting in contact with the person who wrote this and seeing if they'd want help developing the R version of it. So that would be really cool. Again, it's with data cleaning and availability, we want to automate feature engineering. So, turning dates into ages or zip codes into longitude latitudes into zip codes, and kind of helping people avoid pitfalls through, intelligent software design, essentially. We want to add SQL support. Most of the health systems are on MS SQL right now, which was why we started there. But, we're operating system independent right now, and we'd like to be database agnostic as well. So MySQL, Postgres, Oracle, all of that would play nicely, just like SQL Server does. And then we want to add more algorithms finally. So neural networks, we want to simplify deep learning in the same way we've tried to do that with machine learning, which is probably a bit harder, but be a fun challenge, because you gain a lot with huge data sets, and that's what healthcare systems generate. And then we have some applications in unsupervised learning or clustering. So it's like, does patient Joe look similar to all these diabetes patients from a data perspective? And then, adding other algorithms like KNN or XGBoost that we don't have in there right now. And so then just a quick aside, there's also a Python package, but the R package is better. We'd like to develop Python enough to kind of use it to leverage the larger data sets. Implementation is a little bit better. But I think I read somewhere that Tensorflow just got released for R. Did I read that?
Yeah.
Am I making that up?
No, it is.
Thanks. So So maybe we won't need to. We'll see. But you know, you can raise your ceiling of diminishing returns with that kind of functionality. So we definitely want to do that. So enough about Python now. Let's go to a quick R demo. I'll just show you kind of the package, run an example, and then we can move to questions. That is not there. Okay, so the package again can be installed from CRAN, which means that you have all the normal, documentation and help things. So if you type !healthcare.ai, you will get the documentation, which again comes from Roxygen. And so you can click into any of the functions, and it'll give you the description and kind of the things that need to go into it. And then it'll have examples. So I'll just pull one from the IRIS data set, because I'm not convinced that my SQL one will actually work. But you can copy and paste those in. So it'll load the appropriate packages. Let's see, so it runs a lasso model. This is a regression model, so the AUC stuff is in there, but you can, it's just, this is that supervised model class I was talking about. And then from that, you just create the new lasso and run it. And then you create the new random forest and run that. And now you can compare two different models. And so as we build more models, trying a new one will be as easy as this line for the new model. There's also examples for running your own CSV data sets. So you just kind of, it comes with a CSV file that you can play with. That's a diabetes example. But you can really put any file in there. And, same supervised model parameters, same implementation of the algorithm. And then it finally gives an example of how to work with SQL Server. So that's kind of the machine learning that maybe you're more familiar with, kind of model building and evaluation. It also has quite a bit of documentation around if you were to want to deploy a model into production. It's a lot of these same parameters, but then there's going to be a more stringent SQL component to these functions because they're actually going to be writing predictions back to SQL Server.
Or data frame. That's actually
Data frame.
So you can go to Oracle and Postgres if you want. Set to write, data frame to Postgres or whatever it is.
Yeah. So more is always being added because we are always working on it. Okay, back to the lines. So yeah, so if you guys have any questions, well, first I've got to make a shameless plug. Go to our GitHub page, give us a star, please. You can check out the blog. It's at healthcare.ai/blog. And let's see. Yeah, if you want to get involved and help with the development, we've got tons of easy, medium, and hard things that we're trying to do, and they're all on the GitHub issues. So feel free to fork the repo and contribute. The figure kind of just provides a summary of what the package does right now, and I'd be happy to take questions. Thank you.
I may have missed it, but I'm sorry. What in this package is specific to healthcare rather than just being like a conglomerate of predictive models?
Yeah, so that's a great question. So the algorithms we've chosen, you can make the case that they're specific to healthcare because, the linear mixed model especially, because it can handle kind of patient brain at the same time as more longitudinal data. The simplicity and the speed of the algorithms, and then the transparency. I guess that's the biggest thing, because if you're trying to use predictive modeling in a clinical setting, you're going to have a clinician who's looking at the number and saying, why should I trust that number? And so if you're using some kind of really complicated algorithm and it's very convoluted how it works, and it's just hard to generate that trust. So the algorithms we've used are you know, they're more transparent. And then the SQL integration is it's healthcare specific SQL integration, just based on how many health systems are using it that way. And so it does a lot of those kind of, the package does a lot of the things that healthcare environments struggle with machine learning into production. Makes sense. Yeah.
So, sorry about that. You talk about interpretability a lot. What are some of your ideas on making a random forest model interpretable? Because that's a challenge, right?
Yeah, so random forest is really great with feature importance. So it's kind of a, you know, one of those things you get when you use random forest. So we can surface those feature importances and that can help. And then the way I was saying with, you know, providing kind of like a row-wise prediction explanation, like Joe got this risk score because of factors X, Y, and Z. Those come directly from the feature importance. Did you have a question?
So with the specific for healthcare and the SQL, are you doing special stuff to handle like epic structured tables or to work with the epic system of the U or anything like that?
Yeah, so that's an interesting question. Levi can correct me if I'm wrong, but you know, for the most part, once the data is in the data warehouse, it doesn't really interact with the EMR as far as we're concerned. You know, it's put in a data warehouse and loaded into this like kind of disease or application specific table called a SAM that the data architects here build. And once they're in that form, they're kind of like, they're just clean tables, more or less clean tables that we can pull from. And so if you were to use this package like directly from an Epic source or a Cerner source, you would have to do more kind of pulling data from various places to get it all in one place before you push it into the package.
Yeah, so you would kind of aggregate the data first, maybe at a certain grain, like Mike was mentioning. You're able to specify, are you looking at a patient grain or a visit grain or, you know, encounter, whatever you might be looking at, or the financial account. And then once it's kind of aggregated to that level, then you're pulling it in, and it kind of doesn't matter where it's coming from as far as the model is concerned.
So I guess, you know, to answer the follow-up question, yes, this stuff does play nicely with Health Catalyst infrastructure, but it's not written in a way that prohibits it from being used in other applications too. It's like, it's kind of, if you're using it with Health Catalyst, you're happy because it works really nicely. But if you're not, all you have to do is get it to the point where it's in either a SQL table or a CSV that you can run.
But yeah, and even in the SQL one, like the SQL example, they're just kind of pulling from one table in the example, but you can do all the regular joins and things like that that you might need to, as long as, you know, you're accounting for those distinct rows and whatnot, which is really nice. So even if I haven't, when I've done some developing, if I haven't committed to a specific feature yet that I want to pull in, I might join over to a table that has it and you know, mess around with it a little bit and then decide if I want to kind of create a more permanent data set. And I don't know, that's a nice functionality you can need with that.
So maybe this is down the line. So people get their stuff and they act on it, and then you have an intervention. Mm-hmm. So then what happens at that point that you're able to, you know, now that we're doing our phone calls, now that we're double booking, whatever.
Yeah.
What's you know what I'm saying?
Yeah, I know.
Yeah.
I think I know what you mean. So we're going to be trying to do things, like we're going to be checking the model's accuracy. So as we've been putting predictions up onto the server, and those predictions are being say how many of our predictions were correct, how many were wrong. Do we need to make adjustments to the model? So that's kind of, you know, make sure the model stays up to snuff. But then another angle would be, you know, are the predictions actually generating outcomes improvements, which is the whole goal of the process. And so there, we've been talking a lot about how we want to kind of break into a control group and a test group. as far as that goes, to see the impact of our stuff. And that's hard because predictive modeling comes with a whole bunch of other stuff that Health Catalyst provides, at least with our clients. So they're going to get best practices advice, and they're going to get implementation advice on best practices that are surrounding diabetes that we would normally give them, and then also the predictive stuff. So it's easy to be able to say, yeah, if you implemented the diabetes improvement suite and saw improvement, but it's quite a bit harder to decouple the machine learning aspect from everything else. So we've been talking about how to do that. And I don't think we've settled on anything concrete to really show our own benefit yet. That's a great question.
How do you plan to deal with your transparency goal when you start doing neural nets and all the rest of that stuff?
That's a great question as well, and maybe we're going to lose that trend.
Well, that's the awesome thing with Lyme. So you mentioned people from a UW grad student. The idea is that it's model agnostic or algorithm agnostic. So whatever model you're using to create predictions, you simply perturb like Joe's weight or Joe's LDL, and then regenerate a prediction based on whatever algorithm you chose. So you're kind of exploring that space around like where he actually is. It doesn't matter what the algorithm is. You can just kind of see like, oh, if Joe, lowered his LDL by 20 points, the risk would go down significantly. Then you kind of surface that clinician out, you kind of order and see what the most thing improve is. So yeah, Lyme's awesome.
Yeah, you're right. Lyme can help address that. But I think as far as like you're using a neural network now and nobody knows how those really work, is it still transparent? No, it's not. So I guess we'll have to kind of, we're riding the wave of the industry, so we'll see what other people decide. Interpretability is a big question with those non-workhorse algorithms.
In terms of interpretability, does the output of your models just look different from other packages, or how is it more interpretable?
Yeah, so great question. So all models are going to give probability scores, right? And then it's going to be kind of up to the person who's doing the visualization to say how they want to do the visualization. So maybe it'll be a graph form, maybe it'll be reds and greens next to the patients. And then what do we provide on top of that? So we give the probability score, and then we also give 3 column names that were most important to that specific road's prediction. So if the patient is really overweight and at risk for heart failure, you're going to see that weight variable surface as the most important variable. So it's specific to the patient and the patient's values, but also to how the model used all the information to come up with like which features. So it's kind of like a mixture of the patient's specific attributes with the ones that are most important to the model.
Gotcha.
And those are surfaced along with the probability. Yeah.
Just a plug for the people I know who have red-green color blindness, that maybe red-green is the best combination.
Sure. Yeah. I work at Health Catalyst, and we've dealt with a bit of that. And obviously, we do some click-view applications, some Tableau, some web development, and I think Tableau is even especially more aware of that. They'll offer colorblind palettes that you can choose from, which is really nice.
There is a fantastic R package called Cleotus, which is actually based off of research that somebody has gone in and looked across all the spectrum of what's best for colorblind people and created scales that you can use with ggplot2, and that automatically compensates for different kinds of color blindness, and it is fantastic. Make great color scales.
Okay. Yeah. We'll have to do this. Great, ladies and gentlemen. Well, I guess if that's all the questions, we can mingle for the rest of the time or eat the M&Ms, or thanks so much for coming.